Hello and welcome to another episode of On Air with Daikin. I'm Matteo Lombra, your host, and today I'm joined by two very special guests. Let's start with Henry Pelly, Principal Sustainability Consultant at Max Fordham. Welcome.
Thank you.
And a return guest for his second appearance on the podcast so far, my colleague Steve Molloy, Sustainability and Commercial Solution Manager. Welcome back, Steve.
Thank you, Matteo. Good to be back.
Great stuff. So, we were having a great chat before we actually came in, and I think an hour may not be enough to go through everything that we have to discuss, but we'll do our best. I think maybe as good as place as anything to start, maybe if you give us a bit of a background on yourself, how you ended up in the weird and wonderful world of constructions and what's been your journey so far.
Right. Okay. Well, where to start? So I'm an architect, but I've been working as a sustainability consultant at Max Fordham for about 13 years. And my kind of introduction to sustainable construction was actually that I did my part one in architecture, and then I went looking for a way to go to Cambridge in order to row in the boat race. And I saw they had an environmental design
motivation.
in architecture masters. So at that point, Cambridge didn't have a part two in architecture. They'd closed it down, but they had an MPhil in environmental design. And I thought that actually is really interesting to me. I will apply for a 1-year master's after my part one, and I'll do that, and then I'll go and do my part two in architecture, which is normally a 2-year degree somewhere, a master's or a diploma. Anyway, I did that. And then when I was there, Cambridge opened their part two, which was also had an environmental design focus. So I ended up at Cambridge doing 3 years of a research degree in environmental design. And that was in sort of from 2007 till 2010. So I had this background. I kind of was rowing to quite a high level all the time. So I did a part-time master's in environmental psychology, because a lot of the environmental design stuff was around, buildings use energy, but people are the people who use energy in buildings, and we have to understand that. And I was kind of interested in like how we understand how people interact with spaces. So there's one place in the country that does environmental psychology as a degree. So I did that part-time while I was rowing full-time. And then after I did that, I thought, I've got all this knowledge about sustainable construction and environmental design and architecture. I should probably get a job that focuses on that knowledge rather than working for an architecture practice where that knowledge would, that's not what they're looking for in a part two. They're looking for someone who can produce information and develop into a kind of rounded architect. So I ended up doing a short internship at the Architects Journal as a sustainability intern. And then I went and worked at Max Fordham as a sustainability consultant, and been there since. And I did my part three while I was at Max Fordham.
So now I don't know if we should move and change this podcast to building or rowing, because we also have another fellow rower.
Oh, did you?
On
I
the
thought
other
I recognised
side.
the name, and it wasn't. Okay. It's not from the world of work. It's from the world of rowing.
Okay.
Yes.
So
Yeah, I'm quite heavily involved rowing. Well, I've given up a lot, but Remnant Club.
Oh, right. Okay. Yeah, I'm also a Remnant Club member. Are you on the committee?
Yeah.
Right. Okay. Yeah. So I'm a member of London Rowing Club, which is a Remnant Club.
Thought I recognised the
It's
name
a
from
very-
somewhere else.
it's a very small-
yeah.
it's a very
I'm
small
I'm
world.
Kingston Rowing.
Right.
Club,
Okay.
so
Very good.
that's-
Yeah. There we are.
maybe we'll pick up the rowing afterwards.
Afterwards.
And
Yeah. Fair
we'll
enough.
Stick to the
Okay.
building for so far. The reason why I've invited you on the podcast to begin with was in relation to the white paper that Max Fordham released. I think it was April.
It was
this
April.
year?
Yeah.
Which we'll link into the show notes so that everyone can have a read, because it's absolutely a fascinating read. I don't know if there's anything maybe to begin with, because I saw your section. It was specifically around the office well-being in terms of the sort of remodernizing offices and refurbishing offices. So
Yeah.
what is, I don't know, something that motivated you to specifically focus on that area for the document?
Okay. So overall, I was involved in the initial kind of inception of why we produced a white paper.
Okay.
And we, as a practice, have got always had a strong reputation in terms of sustainable design, and from very early on in the practice life, and it's 60 years of us being around. And we just thought it would be really helpful to write something every year where we're honest about where we are on our sustainability journey, and to record the actions that we've taken in each year around, to sort of collate that information, just share it with the industry. I mean, obviously it promotes a practice, but it is about being completely upfront and transparent about what the challenges are and what we need to do. So that is why it kind of leads, for instance, is like where we are in terms of fossil fuel free buildings, and we're sort of over 80% like of projects have no fossil fuel boilers in, which is a complete transformation from say 2017. Over the last 10 years, that is a complete more than a flip from where the industry was. And then explaining where we are and why there may be some legacy systems involved, and a lot of them are to do with it's outside our scope, or so it's a repair. A repair has happened as well as a refurbishment, and we're working on another part of the building, or they're attached to a district heating network, or reasons that at this moment they're out of our control. But we would always be talking to clients about, you are at risk of a stranded asset if you continue to use fossil fuel systems. So there was that, and then then the paper goes and looks at other aspects where we have sort of dived in. So the embodied carbon of MEP, and I was involved in working with a workplace fit out sort of specialist, in terms of they commissioned the work, and we looked at we sort of answered a question about what was the lowest embodied carbon office partition, because it's kind of a common built element, and like what are the issues, and as always it depends. But we used it in kind of like cost and acoustic performance as well as factors, and ultimately there is a good solution. It depends what level of acoustic performance you want. Is one system is lower embodied carbon than the other. And
actually, one of the things that really fascinated me when I was reading through that example was that what you find out was that one of the biggest component was actually the transport from France. If I remember
so
correctly,
which
is kind of crazy, because not crazy, but it's one of those things that I guess you may not necessarily think about or worry about when you say, okay, I'm working on this building here, so I'm just focused on this building. But actually, where are all these bits coming from now? Suddenly,
I mean, like, context sometimes really matters. Normally, we'd say that transport is not a big impact on lots of the upfront or whole life carbon impacts of materials. Like it's sort of 5%. But in the place of office partitions, so when it comes down to it, is that basically a British gypsum system where you don't want particularly high acoustic performance, that's a very low embodied carbon solution. And like, we can't see the difference between all the different, some of the EPDs say things that are different, but if you look at like what they're made from, you're like, yeah, they're pretty much the same. Whereas like if you want a high performance then Thermacell is a better solution, because Thermacell's basically, it's a heavier weight single skin, and it ends up being, if you want better level of acoustic performance, then a different system matters. But Thermacell's impacts, like, they're pretty low in terms of the manufacturing, but the systems all have to come by road, which is currently quite carbon intensive because we haven't got a lot of electric trucks out there. But at the moment, that's a high intensity method of movement, and actually partitions aren't a particularly high embodied carbon part of an office fit out, for instance, or like they're just, we think of them as a large built element, but actually they're pretty low in embodied carbon in comparison.
Mass
in terms of like in terms of the things that you find in buildings, it may look like a wall's quite high in embodied carbon, but like they're actually quite, that choice is less significant than we thought. And credit to Workplace Futures, they invested in doing that study because we were like, this is something we'd like to investigate, and the answer is, it's not that significant, but it's really helpful to know that.
You've got a benchmark.
And we do know what a good system, we can quite quickly, and they know quite quickly what a good system is and isn't. And I think that's another thing, is that we need to be honest about and be upfront about when we do some work and sharing that information. It's like, it's helpful for the industry to understand, when there isn't a big issue, but we still share it with everybody to say, like, this is where we're at.
Data is fundamental. It's the only way to really, let's say, make something that might seem idealistic, like really practical, like in a daily routine. And I think that's also why we started this type of conversation, because we wanted to demystify, maybe it's too big of a word, but within our industry, we hear a lot about sustainability and what we're doing for decarbonization. But sometimes I get the impression that they're very big words, but how do we actually give it meaning to those words so that people can truly believe in the concept, believe in the journey and where we're trying to do. And I think what you've been doing with the white paper, so sharing the data, sharing information, clearly show how any company can go on a journey of decarbonization and what it takes and what are the steps of transformation. It's an example that I think more and more companies should follow to really make sure that the industry can go together on the journey. And we ourselves, sort of Daikin, we are truly believer in terms of data.
Yeah, I mean, it's interesting. I'm just sort of joined the CIBC Embodied Carbon group recently, and there still seems a reluctance from manufacturers to release data about carbon because they feel, oh, it's secret. But we can only seek to improve what's measured. And if we're not open and honest and transparent with the data, and we work collectively, whether it's we had another session with a door manufacturer, actually, us from an HVAC manufacturer, and a discussion with a door manufacturer to see how we can all work together to be aligned in presenting the data to sustainability consultants in a transparent way, so you can make informed decisions. It's not about one company being better than another. It's just putting the data out there and seek to improve.
Yeah, I think there are some steps that everyone has to take. And the first one is just like some transparency about what's happening. And then to be able to demonstrate improvements. And I have been over time like a REBA Awards judge. And, when I did the sustainability, because I'd be the sustainability advisor on the panel, I would have this very clearly you're immediately up a tier if you provided higher quality information. So like making claims with very little information, with very little data to be in that is that's kind of it doesn't matter how good you say it is. If you haven't provided in-use data, you're only going to hit a certain level. Once you're providing some in-use performance data, detailed information on the performance of the project, embodied carbon modeling, no matter how bad those numbers are, you're immediately massively up a tier in terms of that reporting means that it can be understood, you're being honest, and then from that, only when we get to that point can we start pushing on and saying, okay, let's do low embodied carbon design. Because, when I was studying environmental design, my first MPhil thesis was on embodied carbon, and it was just fascinating because in all the papers that were written back then, we just had no idea how much carbon was in buildings. The assumption was it couldn't be any more than a ton of CO2 per meter squared. But we're seeing that in numbers for, buildings where people are trying hard today with lower carbon construction techniques. So those numbers were completely out of kilter. And I think back then the belief was that embodied carbon was about 5% of the whole life emissions of a building. And that probably may have been true with a very dirty electricity grid and fossil fuel systems. But it's sort of like embodied carbon is more significant. We need to have that data. And we're finding that the better we get at embodied carbon modeling, the more carbon we find. So all the data
gets worse before
it has to get worse before it gets better, because we need to get better and better resolution of that data. The more you look, the more you find. The more you understand, the more people who understand buildings who are doing the modelling, the better you are. I mean, that's kind of another sort of things I'll get on a high horse about, but it's really important to have really good domain knowledge to be a sustainability practitioner. Like you need to understand what these things are, how they're put together, what the processes are, like what a wall build-up looks like. I mean, we have this sort of interview question we have for people who come into our team. We show them a wall as drawn by an architect and say, like, what's missing? Because architects don't draw. They're drawing that information for another experienced person to construct it. Like that, all the information is not there. Like everything's not there, but you need to understand you need to have some construction knowledge to be able to say, look, there are some steel wall ties in there and they're probably quite significant and they're at this kind of spacing, and at least know to go and ask somebody those questions. And, I think you find that everywhere. It's like the more that we have construction practitioners becoming sustainability consultants, bringing their knowledge with them, which I think we have in our team, and sort of a focus of what we try to deliver is like some people come up as sustainability consultants, but we make sure that we have lots of people who have experience of the construction side of things in order to make sure that we can do that. We bring that to the decision making.
We found that as an issue because EPD, Environmental Product Declaration.
Yeah.
So it's about the product. So as Daikin, we have an EPD for the outdoor unit.
Yeah.
And an EPD for the indoor unit.
Yeah.
So we submit to this information to sustainability consultants, but they don't just hang there
Yeah.
independently. There is some copper pipe and some wiring, etc. connecting.
Yeah, there's quite a lot of unistrut that goes in,
Exactly.
and like cable trays, and there's it's known what the insulation is, and like it's going to run along. Those pipes are going to insulation run along a cable tray. Like
the cooling doesn't happen by Bluetooth or Wi-Fi.
Not yet.
Not yet. That's something that might come in. But yeah, understanding that there's a degree of copper in there, the embodied carbon, and also what's running in there, because there may be, we can come on to refrigerants later, the embodied carbon of there's extra refrigerant being added depending on the site constraint. So yeah, that's great that somebody like myself has the understanding of the knowledge to, it's unique because you need to build up a whole system and then build the systems to create the whole building.
I think that's that's definitely something that, that's the thing, in the white paper there's a whole thing on the embodied, that Leah Minty, one of my colleagues, has done a really lot of work on the embodied carbon of sort of giving some sort of rules of thumb in terms of embodied carbon of MEP systems, and it's between 10 and 20% for new build upfront carbon, and between 20 and 30 for as a sort of in-use embodied carbon. So the maintenance and, when you include upfront plus the maintenance and replacement cycles, that's kind of where we're at. So it's a really significant portion. And I think when so far there's probably been more innovation in terms of structure, reducing the structure of body carbon and other things. And we can talk about that, and probably not for this podcast, but in some detail. But ultimately, MEP may become even a bigger proportion as other parts improve.
And I think if not a bigger proportion in absolute terms, certainly from an attention point of view, in terms of like the spotlight now shifting from the shell to now, okay, what are all the services that you're putting into the building? And so becoming more of an attention point where we cannot say, it's going to be fine, it's going to work. But we're really having the accurate data can make a difference. I don't know, from a point of view of when you approach like a building design, if you're already at a step where you choose a technology or you choose a provider based on embodied carbon data or not yet.
Yeah, I mean, we're not quite there. We definitely choose a technology based on embodied carbon data, and we've developed a tool to help sort of look at heating and cooling. We've developed a tool to do sort of heating and cooling assessment, including some embodied carbon metrics for where they're at. And, especially in a refurbishment of a existing office building, which is happening more and more. So lots of central London planning policies really push up against not doing, new demolition and rebuild is absolutely out. And therefore we've got to make existing buildings work. In those refurbishment office projects, you can get up to 40% of the embodied carbon of the whole project is the MEP. So it's like a really big focus. But yeah, I mean, basically when you have lots of refrigerant, like the volume of refrigerant and the fact that those refrigerants, when they're in VRF or VRV systems, they need to be at low flammability, which means that they're going to be, have a higher GWP. I mean, I think I talk about this quite a lot. There's this I say refrigerants either not very good, it doesn't perform very well, or it's murderous to people, or it's terrible for the environment. And you've got to pick your poison and work out your trade-off. So R32 is like quite bad for the environment, but not going to immediately, but it's like pretty safe. And actually, it's not going to burn the building down if it explodes. And, so it's sort of like that at the moment seems to be the right payoff. But, things like ammonia, which are incredibly toxic, might be back in. And then so CO2 is probably good. CO2 is like a low GWP refrigerant, but it's weird. Has very weird properties. Like it's not applicable in lots of places. I'm not an expert on CO2, but
we actually started
is like
with CO2. So I mean, as you can imagine, for a company like Daikin, working with refrigerant is what we do on a daily basis, pretty much, and not really what we do today. But we're always thinking like 10, 15 years down the line of how can we change, how can we improve, where we can go, where we can take the technology. So we certainly see the R32 piece as being the refrigerator for today and for the future, but we're already looking forward the next steps. So we started working with CO2, Steve, right?
We just had the first CO2 VRV system installed and commissioned 2 weeks ago.
Oh wow! Okay.
So it's very
coming.
You actually hit the nail on the head when you're saying you've got all these balance points. And Matteo and I do a lot of presentations at the moment. I'll be speaking this week at Elemental Live. about the same. It's finding the right refrigerant for the right application.
Yeah.
And when we started with Daikin, it was easy. You just had R410A.
Yeah.
In everything. That was
Yeah.
it was easy.
It's great in every application apart from its climate. It's like it's global. It's global warming potential. It's like good for every. It's like if you're not thinking about that factor.
Yeah. I mean, it was certainly, to be fair, it was also a result of what was the global thinking at the time.
Yeah,
At the
totally.
time, we were not worried about that. We were worried about the ozone layer.
Yeah.
Then attention shifted to global warming potential, and therefore, okay, where do we go next? So it's kind of like that's also like a very fascinating part of working in the industry that we work, because you're constantly chasing a moving target to a certain degree. So you're always on your toes to see,
I mean, the ground's always shifting.
How do we evolve the technology? How do we improve? How do we make it better, safer? And of course, for us, the safety is like really key, because it's not just safe when it's there, but it's also factory level, transport, install, service, commission, maintenance. So all those steps are are massively important. Of course, the environment. How do we make it the best choice for the environment? But it's a constantly evolving situation.
Yeah, it's like R290 now is a lot of people say, "Oh, what's R290?" It's basically propane.
Yeah.
They don't know the term R290, but they understand propane. Go, oh,
yeah.
But it's just getting over that. It is potentially safer to work with. Yeah. People forget that their gas barbecues outside have butane or propane in there. It's the same sort of principle. It's people are scared of change sometimes, and
because I always make the reference to the point that in our houses we've been using natural gas for ever, which is used. Why? Because it's very easy to ignite and produce heat and use that heat in a way to heat up your home, and we're all fine with that. I think what we're always trying to say is fundamental is that as long as you know what you're working with, you can always find a way to do so in a very safe way. So the most important thing from our point of view as well, and what we always try to do, is making sure that we do as much of that pre-work and pre-research at design stage and factory stage. So when we design the new products, we say, okay, this product is going to be installed in this type of settings. We'll use this type of refrigerant. What do we need to do so that we remove all the burden from the industry? So then designers, installers can just run with the product, having sort of the knowledge that we've done a lot of work behind the scene to remove as many possible obstacles down the road, to make sure that the technology, because fundamentally, kind of like the catch-22 in a sense is that we know that the direction is toward electrification in general. So we want to make sure the technology is used as much as possible. Then the question becomes, as a responsible manufacturer, how do we remove any possible barriers for the adoption of technology so that the product itself doesn't become a barrier to its own adoption in a sense? And the only way to do so is to spend the hours in the R&D at the factory to do the product in the most possible right way.
Yeah, I mean, but if you look, going back to the point, the whole life carbon, if you look at the EPD of our R32 based unit and the EPD of our CO2 based unit, holistically, the R32 still wins.
Right. Okay.
Because it might not be as efficient as the R32 at the
right. Okay.
The operational carbon is still very high. I think you used the word the grid was dirty at the time.
Yeah, I mean that's the transformation, isn't it? I mean it's so. In my career as a sustainability consultant, I started with over 0.5 kilogram of CO2 emitted for every kilowatt hour of electricity produced, and now it's like 120 or something, and continuing. It's clearly continuing to drop. And I think the kind of positive thing from a global level is that it's pretty clear that renewable electricity is outgrowing fossil growth. So energy growth is growing overall. But in terms of like actual energy services, not primary energy use, which is like two separate things, but basically it does look like it's a 3% outcompete a year from renewables. So basically we're going to end up with no fossil fuels anywhere by 2060, just through the fact that renewables are getting cheaper and cheaper, the learning rates for batteries and PV. So it's like, that's all happening. So those assumptions, I think when we do that modeling, I think one of the things that as sustainability consultants, we often, we're so used to it being such hard work to try and like persuade people to do things, we get overly negative about what's happening outside in the world. And for me, like, it just happens that my career has spanned like a few years of working with a dirty grid, electricity being like, electricity and cooling being a terrible thing to use anything of, to the fact when like now it's like, well, obviously cooling's happening at the same time as we've got overproduction of solar electricity. There's no moral problem with that whatsoever. In fact, it may be sometimes like holistically the right thing to do from a energy perspective or embodied carbon perspective, let alone just a health and well-being perspective. So I think if I see there's one thing the industry should be working at, it's being like knowing that it's sort of factoring upsides and making decisions around the things like don't be so negative about the way things are going to go, because actually they're pretty like in lots of places that like in lots of spaces we're doing a great job. Embodied carbon is probably one of the hardest areas to tackle.
Yeah, I think it's just look at the stats. I think it was last year worldwide, 40% of electricity production was from clean energy.
Yeah,
I've seen a report last week that it's going to outdo it this year. I guess as I said, overall electricity demand is going up, but that proportion that's coming from clean energy is growing, and it's going to tip the balance.
Yeah.
And sometimes I think we get a bit insular in the UK, thinking the rest of the world's not doing well of what might be happening in the US.
Yeah.
Look actually at China.
Yeah, I know,
China
is
solar.
the new electrode power.
Exactly. They're doing really well in this sphere. So maybe we can, as you said, stop criticising on sometimes the downside. Look at the upside.
Well, I think the other thing is I saw someone has published so you know what Sankey diagrams are, showing energy flows. Mm-hmm. And they're really helpful way of saying like, okay, fossil fuels, you put a lot of energy in and you get a bit of energy services out, like a third of the energy services out, and that's renewables. You don't get that. You get like 1 for 1. But the interesting thing is that this first Sankey diagram that's been published for like the US includes ambient air. So it's like at the moment, like 3% of the US's energy services are basically is ambient air. It's heat pumps taking energy out of the air, and that is a really important flow. And that's going to increase to like, it'll be like 10% of total energy we use or more will be energy that we're taking out of, a free resource that is absolutely renewable. And I think the way we, starting to visualize things in that way and understanding that's the role of heat pumps. I think that's one of the things is like, I think there's a lot of discussion about, heating and cooling systems, but like the unbelievably huge carbon benefits of heat pumps and other forms of, heat pumps of every variety is it's almost like we try and focus so much on the benefits to the user that we forget that the really big benefit is it's very low carbon.
Yeah, no, you're absolutely right. And I think, that's certainly an area where, again, manufacturer like us we always try to improve the way that we portray the technology out with the, let's call it the non-initiated to the industry that don't know exactly how it works. Because I think sometimes you can see how it might be counterintuitive, like the idea of you only put something in, but you get more out than what you actually put in.
Yeah.
It's very different from what everybody's used to, again, with a gas boiler, where you put in and you get less than what you put in.
Yeah.
And it's kind of like, it takes a bit of a shift, I guess.
I think it's really hard to visualize, and also like it's the sort of like, it's a fridge backwards is also just doesn't really help.
Yeah.
Ultimately you're taking quite cold air and running it over something that is incredibly cold and then expanding it, and you know what I mean? We're taking heat out of coldish air and turning. It's just like it's hard to visualize unless you really have like seen it happen. And I'm going to assume that the viewers of this podcast will understand that, but I think for a lot of people, it's just such a hard. It's such a hard thing.
It's all over the place
to get your head around how it happens.
Yeah.
But ultimately, like and I've seen people do lots of different kind of visualizations to describe it. But people don't want to think too hard about their heat or cooling. They just want the comfort.
That's true.
That's the issue.
Am I comfortable?
Because
yes
we've got so many other things to deal with that are just much more important.
Absolutely.
That like the biggest issue I think in the heating transition is that the only people who are getting heat pumps are those who are thinking really, really hard about it.
Yeah.
And that's not a natural state to be in.
I think if you really want to, again, demystify technology and making sure that it can be really widely adopted, you need to be able to explain how it works and what it is. Because I think people naturally, like, if you don't know how it works, you tend to be a bit more diffident in terms of saying, is it actually true? Am I actually gonna get what they said I'm gonna get? Because if you cannot really visualize it in your head, it's like it takes a small leap of faith, shall we say, in terms of adopting the technology. So that's certainly an area where we always try to
Yeah, I think
improve.
that's why. So it's taken to another conversation we've had, like the bus grant conversation. So
Yes.
like the heat pump grant. There's been like there was this Guardian article earlier on last week where somebody, I think a Treasury special advisor, didn't really know what he was talking about and was basically claimed that he made some comment where he said, "Oh, the middle, taxes shouldn't be paying for the middle classes heat pumps," but actually I think he didn't really understand that eco is what is probably up for the chop and not the bus grant. So and that the point of the bus grant is that you can get a critical mass of helping installers build up their businesses, but you can get a critical mass of these devices working in people's homes, and you can go to you can see that this technology actually works better than your current gas boiler system, and once you've got that social proof, they will take off. But at the moment, they're only in like a small proportion of people's homes, and it's really hard to visualize how it might work. And you hear, if you go on a heat pump forum, it'll be just
That's
people.
a dangerous place
It'll just be
to go
people.
sometimes.
It'll just be people who really want help with the systems that don't work. Not no one's going to go on there and say, there are a few posts like this, but not very many. No one's going to waste their time going on and saying, you know what, my heating system works perfectly well and it's exactly 21 degrees all the time because my weather compensation has been set up correctly and my installer knew what he was doing. Like, no one posts that kind of stuff. They post for help. Like, the internet is mainly for people to learn how to do things. So
it doesn't matter if it's domestic heat pumps or to else, because we're seeing the same side on the commercial heat pumps. People still not trusting commercial heat pumps are replacing the boilers. It's interesting, the stat I think you gave earlier, 80% shift you've seen on the decarb, and it's people are still, should we say, they don't want to trust something they don't understand. And we see schemes with heat pumps in with 100% boiler backup.
Right. Okay.
That's sort of,
They're
just testing the water, trying to see there, but still.
Well, then it is a really expensive thing to do.
Exactly.
Because we did. There was Salix funding for lots of projects, and we have done lots of Oxbridge colleges. So we have put COT heat pumps in a project where we needed to basically it was a 20th century listed building. They needed to maintain the existing radiators. They couldn't do very much with the fabric, and therefore it needed a much higher temperature system. So therefore we had a CO2 heat pump when we got there's a SCOP of a bit above 3, which is pretty good for that kind of level of performance. So we've done that, and that kind of created the social proof for other colleges to go ahead and run their own decarbonisation projects, in which they have probably those ones a bit more conventional heat pump engineering, but it does take some people to lead and demonstrate that that approach works.
Are you finding you're being employed to do the after install testing and monitoring of how the systems are actually
so I mean that was something. So when I first joined Max Fordham, growing our post occupancy evaluation work and what we would term like soft landings, which is actually the lead in and the handover and the commissioning and the kind of long term hand holding for the projects was the service we were developing, because there was definitely a narrative in the sort of early 2010s where buildings weren't performing anywhere near as designed. We're like, this should be low energy, but it's not performing that well.
The performance
gap
was always mentioned, but nothing ever was done. Designed for compliance, not designed for occupancy.
And like the compliance, that whole bit of it was like, because obviously the compliance modelling is not predictive energy modelling at all. So there's a bit of that, but also there's a huge difference between what's designed and is it actually set up and commissioned to work that way. So there was certainly for my first sort of 7 or 8 years in the practice, I did a lot of that work, and I ran the soft landings process on this sports centre called Ravelin, so the University of Portsmouth, which is the first BREEAM outstanding sports centre. So I ran the BREEAM on it, but also ran the soft landings process, which in order to make handovers work, in order to make the aftercare work, you need to be engaging deeply with the operation and the facilities management staff before the building gets built, and all the way through the process. Even in the construction process, you want to be saying, this is what we're proposing. That the University of Portsmouth were pretty progressive. They had a BMS guy who was the university's BMS guy, and everything was made sure that he, it was all set up so that he worked, he understood what was coming. The reactive and preventative maintenance team understood what was coming. They'd never run a pool before. It was their first pool. It's like all these things, and just trying to keep them briefed and running workshops and making sure there were some building tours happening so that the facilities management could go around while it's being built and see where everything was and how it worked.
So what drove that? Was that the client driving?
So they had this Deck A energy target. So the display energy certificate is required for public buildings at university than every building. And we did an energy master plan for them before that project, saying, you know, these are the sort of sustainability and energy plans for their like, you know, huge number of projects that they had planned. And we said, this is what we think you should try and do. And that Deck A target represented huge energy savings for them. So Deck A is a top quarter of that kind of building in terms of energy performance. So we set that target. And interestingly, that was around this sort of project started in 2017. So the key point was at that, the grid was decarbonising. It had decarbonised quite a bit already, like sort of 3 years of this kind of dramatic drop, but it hadn't yet fully, and they hadn't updated the deck methodology. So we were saying you need to do this with heat pumps, because by the time it's built, you'll really regret having any fossil fuel system in there. So it has to be done with heat pumps. And, you know, we had to sort of, when we had initial contractors on board, they were all like, oh, have you thought about CHP? It'll work better under the deck methodology, et cetera, because at that point, the electricity carbon factor for the deck was not particularly good for heat pumps, but the reality would be much lower. So anyway, that project, I mean, that would be the unicorn. Like, no project has worked as well as that. Like, the contractors wait for everyone worked really constructively on the project.
And this is what I think it's just, I call it supply chain alignment. Everybody has got to be aligned, you know, and it's interesting what you say about facilities management. I think that's probably one of the biggest opportunities we have is actually educating the facilities management, because they're the ones running it and they've got to understand.
Yeah, and they've got to like understand when it's not being you know, they could be able to spot themselves that things haven't been commissioned the way, you know, in the way they're meant to be, and they're not quite operating, and they, you know, have that knowledge. I mean, so that Raven Sports Centre, it's got a energy use intensity. It's got a pool. It's very highly used. The energy use intensity across the whole thing on average is 118 kilowatt hours per meter squared per year. But there's a big PV array, so actually, like, what comes from the grid is like 86 kilowatt hours per meter squared per year. It's like well below a Deck A, and I really wish we'd run soft landings on a sort of risk basis where we got paid some of the savings, because it costs them about £250,000 a year to run, and a typical building would be about a typical sports centre, like a Deck C sports centre, would have been like £2.5 million a year to run. So, like, I mean, that swamped anything that looked like our fees. But, like, you know, that is what good engineering, but good coordination. And I think that kind of, a lot of that soft landings process is about making sure the contractor's allowed for the level of meetings. So, like, writing documentation so that they have an allowance to engage all the way through, like having a really clear, you know, sort of building delivery plan, making sure the contractor is writing a building readiness plan, describing how they're going to do things, and then just holding them to it. And I think when everyone's agreed that they're going to do a process, it's totally fine. It's more that it's harder for a main contractor if they haven't allowed for doing a certain level of work, and that's eating into what are quite fine profit margins in the construction industry. So it's like, I understand why they try to do like only what they're contracted to and no more. So it's just making sure that you when you tender these projects, that you have like a really comprehensive set of prelims that it sets out exactly what you're expecting from all members of the supply chain, and that they're all tendering against that. And that little extra allowance is put in for doing that work because it pays huge dividends.
Just saying, that value to the client, that's
massive.
That's a brilliant case study, I think, from what we're trying to achieve. And at the end of the day, it's decarbonisation, but that's saving pound notes for the end client. I
think there's Dakin R410 heat pumps in that project. That's really interesting. Is like, we did it before we understood the implications. Like, we weren't really on top of refrigerants then. So the building is in many ways.
And it's crazy, like, because it was, if you think about it in the grand scheme of things, you said it was only 2017. So
it was finished in 2022. It was finished in 2022. It was finished like 3 years ago.
Yeah, but in such a small span of time, the conversation on refrigerant has basically turned on its head.
Yeah, it wouldn't pass. It fails one of the key tests of the new net zero carbon standard. Even though, in many ways, even though the energy use intensity is like at 2040 levels of performance.
Yeah.
It's like, okay, well, key metric failed against, does not comply.
Yeah.
I mean, the embodied carbon as well, like, I think it would perhaps comply with the embodied carbon targets too for the new build,
think
But
it
like,
sounds that number from what I've seen from the pilot standard, that's
yeah,
well
but it's
within.
just like, so it's just like, okay, so that's something that we didn't. I mean, I honestly, like, my knowledge about refrigerant in the last 3 or 4 years has significantly increased as that's come to the fore as we're dealing with other issues.
Yeah. No, exactly. And we saw it in the same amount of time, the amount of request, the amount of scrutiny that was suddenly being placed on refrigerant, whereas before it was not forgotten about, but let's say, okay, yes, it's a heat pump, it has refrigerant because that's how it works,
Yeah.
full stop, to then how much, what are you planning, how much extra needs to go, what are you doing, I don't know, from a decommissioning older systems, are you reclaiming, are you recycling, like, it's been an unbelievable journey in such a small amount of time, seeing that massive transformation that kind of also took us a bit by surprise to begin with, because again, we were not necessarily used to this kind of conversation. So even ourselves, we had to really quickly adapt and make sure that, almost like trying to bring full circle in the conversation, we had all the data right there to be able to show exactly how much, what, where it's coming from, building up all the knowledge that we built in terms of reclaiming and reusing refrigerant, and try to phase out as much as possible the use of virgin refrigerant. Massive transformation in such a rapid amount of time.
Yeah.
Almost like unbelievable from from our industry that sometimes moves a bit slowly.
Yeah, well,
in
and
a
it takes a
sense.
while to do R&D and
Yeah,
like
exactly.
develop the products and bring them to market. And
Well, that's why we're starting with CO2 VRV
Yeah,
now.
yeah,
You know,
yeah.
it's actually we've got it out now, but the plan is a longer development in line with the F-gas regulations in 5, 7, 8 years' time.
yeah.
But we're starting that journey now.
I think one of those things that the other conversation we had before this was to talk about the kind of reporting rules around
Yes,
refrigerant and refrigerant leakage.
the lack thereof.
And that,
shall we
well,
say.
yeah, the lack thereof from a kind of, you know, there isn't, like, I don't think us three aren't aware of really good data in the UK on like actual refrigerant leakage rates. And there
guess
is
it
like
really boils
the
down to the
default
fact-
numbers make VRF systems, which are really efficient in terms of operation, it makes them look pretty poor from a whole life carbon perspective. And I think we all think that, you know, from that previous conversation, that perhaps those, you know, there should be I think personally there should be a scheme which rewards good quality assurance, so you can end up with, like, for subcontractors that are putting these systems in.
Yeah. But I
they
think even simpler than
demonstrate
that,
performance
to
in
begin
order to
with,
reduce that leakage rate.
just create a database
Yeah.
where you need to fill that information, because I think actually the information exists. The problem is that it's literally stuck on the
On a
underside
spreadsheet, yeah.
of the unit installed on a roof somewhere.
Yeah.
And I remember reading, I think it was the South Bank University in London, that they did a study like 10, 15 years ago. And they literally they took students and they sent them around the roofs around London to check units by unit what was the F-gas record. Because as I said, the data exists, but it's in the way that it exists now, it's like it's not there to be.
Yeah, but it's not in terms of, we don't know we don't know how many are actually failing.
Oh no, absolutely.
Yeah, and like that data. So
certainly
it's like the two
not at a
things.
scale that can be used to define trends, to define schemes, define legislations, or
because I think
things like that.
I think we both think the 6%. So there's a 6% figure for systems.
Yeah.
Which
So
is
basically, to give some context for all the audience that might not necessarily know, but when you look at things like TM65 and SIPSI, when you need to account for the annual leakage rate, the moment for a VRF, VRV type of system, you have 6% of an annual leakage rate. If you look at EPDs, 2%. Where the number comes from? If you read through some of the documents, you see it's like studies done over the last 20 years, but never necessarily updated. So maybe study done on previous generation technology. Going back to what you were saying, quality of installation, again, like the practice, the actual technology, the knowledge, the tools, everything has evolved. So you would assume that everything contributes to reducing that number. But that number is kind of stuck there since
it just feels
the very
like
inception.
The vast majority of installers will have systems that are not going to fail, and that should be recorded, and they should probably get the benefit of them. And those installers who are putting in systems that are failing, like they should probably have the same recorded performance. And, like, you know, if you choose to use an installer who has a record of failures, then perhaps, you know, that should be counted against the installer, whereas the whole industry being penalized in a very kind of flat way, this is the leakage rate. It just feels like a scheme that incentivizes
This is where we're
like good brazing and like good working practices would be like incredibly valuable for this particular aspect. And I don't, it's not like it's all new data. Like just Refcom having a platform where you put in your data for the projects, and when one's failed, that like a customer's able to report against a failure of one of your systems would be like a really effective way of managing things.
And this is how we're working with our installation partners. So our installers through our D1 Plus scheme, in order to get the top warranty, they have to maintain that equipment as well. So if they're installing and maintaining, they're the ones holding the records.
Yeah.
There are software packages that we are speaking to them all that they do hold with all these F-gas records. So what we talked about in the first Daikin On Air podcast about with our decarbonisation partner scheme, we're working with them to share data.
Right, okay.
So each and every one of them has been perfectly open to say, yes, we're happy to share the data. The sites we're monitoring, the sites we're maintaining, we will help collect that data, seeing what's happening with them and feed them back. Anonymised, because we don't need to know, is a particular site not performing, but we can build up a picture.
Yeah.
And that's the only, as it goes, well, we said right from the beginning, we've got to get to data
Yeah.
to seek to improve.
Yeah.
We don't know, there's been a study in Germany that they're saying leakage rate is probably, less than 1%. So
yeah. Which I think is more believable, frankly.
Yeah.
I mean, that's...
But also, like what we've been saying all throughout this episode so far is that we reckon the importance of embodied carbon is only going to grow. We also understand, especially in refurbishment type of applications, the focus on MEP, that annual leakage percentage rate can make a huge difference.
Yeah.
Like even if you don't change the technology, you don't change the refrigerant, but you just take that percentage, you move it down, everything changes immediately and completely in terms of what is the final picture. And so it seems crazy in a sense that that number is just assumed as an absolute truth.
Yeah.
Given all the other things that are changing, all the other studies, all the other focus on embodied carbon in general, it's almost like now it's really the time to put some effort, some energy, resource, money, whatever that might be, to actually reassess, is that the right number? Should we change it? Should we do an actual study?
Yeah.
It's weird that, I don't know, there's not been any desire to truly change the number, and it's just assumed that it is what it is because it's printed somewhere on a guide.
It was a placeholder, but now's the time. Now it has massive implications for decisions that people are making in terms of because ultimately any electrified system is still much better than a fossil fuel one. Yeah. Like no matter what refrigerant you have in it, like it'll be better.
Yeah.
But
it could be significantly better.
But it's sort of like in that. It would just, now we've got a starting point, a number. We've just got to make sure that we work out a way to incentivize good installations and good practices, and like disincentivize poor installations, and allow some kind of application of those, rather than just tarring everyone with like the same brush of it's going to be have a big impact.
Maybe something similar will happen that we saw with the UK net zero carbon building standard that came off the industry directly. Maybe another collective can come together and say, now is the time to revise that.
Well, it just feels like number. The F-gas, Refcom, people who are like that, like it feels like the partners involved in that, they have a place, and the environment agent, and like as I said, like so Job Logic and other platforms, like they're collecting that information. Like, can that just be shared in a helpful way? And I think you're right. You start off by maybe you start off by not penalising installers for their reporting.
We don't want to penalise. We just want to seek to get
work
better.
out what the base rate is, and then understand what the factors are, and then develop a scheme for making sure that those factors are managed. Because we said you're investing in R&D for different systems, and actually it could be that the existing refrigerants are more fit for purpose than we think, because we can assume a better performance,
because the leak,
better control measures.
It's got global warming potential. global warming potential only if it's released
Need
into
to-
the atmosphere.
yeah, exactly.
And, we've talked about previously that actually refrigerant is a commodity. It's actually, and with the recycling schemes that are available there, it can be used and reused again. It's not, and it's only at end of life when it's incinerated, after multiple times of reuse, but it's got an infinite number of times it can be reused. And, we've done studies, reclaiming R410A is 90% less carbon intensive than producing virgin R410A.
Right, okay,
So, it's just great for the whole circular economy piece in terms of that, but it's still got a global warming potential
if it gets out.
If it gets out.
Exactly. Well, as I knew was going to happen, we've run out of time, and I know that we could have been here for another day. So maybe
So I'm touched of some of the topics we want to
no,
discuss.
exactly. But we'll definitely have to have you back to continue the conversation. Now I think it's time to move on the rowing side of the podcast. once we go off the air.
Yeah, we'll go and do an ergo test in the gym.
But again, Harry, thank you so much for joining us.
Thank you very much
today.
for having me.
It was a great conversation. Steve, thanks for coming back.
It was a pleasure.
Thanks all for joining us. We'll have all the links in the descriptions to all the documents that we discuss and some other bits and pieces that we discuss. If you're not subscribed already, get subscribed on YouTube, Apple Podcasts, Spotify, all the places where you normally get your podcast. And I'll see you in the next episode.